I want to go through how to do some alpha-beta decay problems. First of all, in order to figure these out, you need to know what an alpha particle is. Well, an alpha particle, abbreviated with the alpha symbol, is simply a helium nucleus. Well, a helium nucleus has a mass of 4 and an atomic number or charge of 2. So to write the symbol for an alpha particle, you write down its chemical symbol. The mass number is written on the top up here, and your charge is written on the bottom. That would be alpha. Beta is simply an electron. Well, the mass of an electron is 0, and the charge of an electron is -1. So if we want to do alpha or beta decay problems, what's going on is you've got a substance that might be radioactive. If it undergoes radioactive decay and it gives off an alpha particle, what's going to happen is this thing right here is going to have an alpha particle break free. So you started with something and you're left with two things. A new element and an alpha particle. So how does this look? Well, let's pretend I have polonium-208. If I wanted to write down polonium-208, the 208 tells you the mass. I can look up the atomic number of polonium from the chart, and it looks like it's 84. And we'll have to tell you whether it undergoes alpha or beta decay. Well, if this undergoes alpha decay, this is going to turn into an alpha particle, which is a helium nucleus, mass of 4, charge of 2. That's this thing right here. So it gave off some small little particle out of the hole. And the question is, what is left over for that? Well, if the original mass was 208, and 4 units of mass turned into the helium, that means there's 204 left over for the new substance. If the original charge was 84, and you have a charge of 2 in the helium, that means there's 82 left over for the new substance. And what has atomic number 82? Well, that happens to be lead. So this would be the equation for the alpha decay of polonium-208. Here I started with PO208. It turned into lead-204 and an alpha particle, which is a helium nucleus. If you want to do an example of beta decay, well, same thing. It's radioactive. Let's assume I have iodine-131. Iodine-131. Well, we've got to figure out what I'm starting with. The 131 is the mass. The atomic number of iodine is 53. That's my original radioactive particle. If it's radioactive, that just means it's going to spontaneously emit radiation. In this case, it's spontaneously emitting a beta particle. What did we say beta was? Well, beta is an electron with a mass of 0 and a charge of -1. Mass has to be conserved, which means my new substance has a mass of 131. What's the charge of the new substance? Well, some people will say 52, but it's really 54. And if you think about it, 54 plus -1 does in fact equal 53. So what element has an atomic number of 54? That would be xenon. So with these decay problems, you start with some radioactive substance, and it will either undergo an alpha decay, which is a helium nucleus, or a beta decay, and in either case you get something new. Just make sure your mass and your charge is conserved.